Can we turn the volume up a little bit? All right, how's that now, Kirsten? Okay. All right. So I'll just repeat that because you couldn't hear me. All right. So welcome to our 14th edition of E&IP at ATE. Happy to be back in Detroit. It was 5 years ago that we were here last. My name is Rudi Schubert. I'm from the IEEE Standards Association, so I'll be sort of the MC for the next 2 days, introducing speakers. If you have any questions that come up over the course of the days, feel free to stop at the registration desk where my colleagues Rosalinda and Jen are happy to help with anything that you need. I think most people here are quite familiar with IEEE and have been to the event many times in the past, but for those who may be a little bit less, IEEE is a membership organization of, I think we're over 460,000 members at this point. I'm actually from the department that does standards, so we have well over 1,000 standards, and the 802.3 Ethernet standards are certainly among the most prominent and well-known, and the best attended standards that we have, spanning not just automotive applications, but just about any application that you think of where Ethernet comes into play. So today we'll be starting off with a great set of talks. First off, I wanted to thank Ford for being our host in Detroit. So a round of applause for Ford. A few other thank yous. This event doesn't happen easily. So we have a steering committee, many of whom have been on the committee for many, many years, really assuring that everything is organized well and is meeting the needs of all of you who are professionals in the industry, as well as a program committee that does the painstaking task of going through numerous presentations. It's always difficult to try to down select all the papers that come in, because we can only usually fit somewhere between 15 to 20 presentations tops, and we usually get 60 plus submissions every year. So a lot of thanks to Chris Nash and John Simon, who are the chairs of the program committee. Of course, thanks to our exhibitors. We have 2 exhibit areas, if you haven't noticed right on your way in. They're on either side of this hall, so it's about evenly split. We encourage you to visit all the exhibitors for the next couple of days. I think that's one of the great displays showing the latest technologies that their companies are providing and promoting. Just a couple of housekeeping items to go through. There are restrooms that way. If you go out to the hall and go to the right, there's also some secret hidden ones that I found all the way in the back area as well. Emergency exits. Hopefully we don't have an emergency. There's a staircase right next to the elevators. So I think that's your primary emergency exit. We will be having our breaks, our coffee and refreshment breaks, in the exhibit rooms this year. We won't be out in the lobby, but we want to get you into the exhibit areas. So I think around 10:30ish, we'll have our morning break. There's coffee and some pastries and other snacks, as well as an afternoon break each day. And a couple other things. This year, we've started partnering more with the Open Alliance, and I just want to thank Open Alliance for their nice reception, along with Intrepid last night. And as if that wasn't enough, you get another reception tonight. As part of the official conference reception will be tonight, and that will be downstairs in the Windsor room. Just one last note, if you are a speaker, speakers should actually visit the AV table, show up like 5 minutes before your talk, just so you can get mic'd up as well, and you're all ready to go. And probably forgetting to thank somebody, but once again, I'm going to encourage you to please visit the exhibitors. We should have plenty of time. The exhibits are open before the sessions start in the morning, on the breaks, during lunch, and I think that'll be great if you can visit them all. So with that, I didn't want to keep talking here, and I actually want to turn it over to our host company, Ford, and we'll start out with introducing Amrit. And Amrit is the chair of this year's conference, so big welcome to Amrit.
Hello everyone, and welcome. Ford is excited to be hosting this year's event. This is the 14th edition of this event. Ford actually hosted this event back in 2019. A lot has changed since then. A few global events and a few organizations in automotive have gotten Ethernet deeper into the way. So I thought it would be good to look at a few things that have happened since then and how Ethernet has evolved in order to kick off this event. So I was looking at presentations from 2019. I found a lot of presentations that focused on autonomous vehicles and infrastructure needed to support that. Since then, we've also had the global pandemic, chip shortages, and supply chain issues. All of these things have slowed down the pace of development, but also opened up new areas for automotive to focus on. Every major OEM has announced EV platforms. So what electric vehicles allow us to do is it provides us with more digital features. And also digital experiences have become a core offering from major OEMs, which it's now becoming a differentiating factor. And hands-free driving has also become something that's more common. We are able to do this with more safely and more cost effectively. And I think all of these features and trends have always needed a network that is more robust, a network that's faster, safer, and most importantly, a network that can scale. And Automotive Ethernet has been answering this call for many domains and has been getting deeper into the vehicle. Ethernet was first used in using the Bluetooth pad, where they used it for onboard diagnostics. This had to be limited because it wasn't designed for the EMC environment of the vehicle, so they could use it only in certain times. But then in 2015, we had the single crystal pad 100 megabit Ethernet standard, which was a game changer. That opened up the floodgates to the rest of the speed grades, and each of these speed grades were developed for different use cases. And some of them have made it to mass production, whereas others are still being tested in labs. Asymmetrical Ethernet is actually currently being developed, and I think it will change the way we look at audio, video, and display links in the future. So last year when I attended this conference, I got the opportunity to meet Bob Metcalf. He's one of the co-inventors of Ethernet, and he gave us his perspective of why Ethernet was so successful. We had this open session where he answered our questions, and he gave us his rundown. So one of the things he said was Ethernet is a brand, an innovation brand. So the reason it's been so successful is it's developed using standards, and a lot of vendors as well as people who use this come together, individuals come together and then create the standard. He said because of this openness and interoperability and other things, Ethernet has made it further and further into different use cases. So each time we needed something new, we would define a new physical layer, and the rest of the Ethernet stack can be used. So a lot of devices have been getting the Ethernet brand, and that makes it very powerful, and the number of compatible devices is just low. Another thing is from Jeff Thompson. He was an early customer of Ethernet and Ethernet contributor. He also says that because of the way Ethernet is developed in standards, the number of vendors that produce this product as well as use this product makes it cost effective. And another key thing is because of so much of involvement, it's plug and play. So even though it's a complicated technology to implement to get the packet from one point to the other, it still works, and now it's everywhere. So standards are a key to lowering cost, improving quality, and creating better products. Apart from IEEE, there are other few standard organizations that have helped fill gaps to bring Ethernet from concept of the standard all the way to production. So these would involve defining interoperability testing or conformance testing, or just defining features that cannot be defined in IEEE for some reason. And all of these have helped get Ethernet deeper and deeper into the vehicle. And different domains have picked up Ethernet as time has progressed. So for for this year, our theme is Can Automotive Ethernet Scale Infinitely? I think we have a lot of great presentations that will talk about gaps in order to get there, and also learnings from Ethernet so far. And I hope you enjoy this program. And so for people who have traveled to Detroit, I hope you enjoy our Motor City as well. Thanks. I would like to introduce our keynote speaker, Shareef Hakim. He is an executive director of Systems Lifecycle Organization at Ford. His team is responsible for a wide range of functions, including platform and feature definition, system architecture, integration and validation. They ensure that the latest architecture platform is both robust and adaptable and capable of seamlessly integrating with a wide range of technologies and services. So Shareef has a deep understanding of the current limitations that prevent us from moving faster. Prior to joining Ford, Shareef served as the Senior Director of Cloud Platforms and Infrastructure at Intel, where he played a key role in driving performance architectures of Intel processors. Please join me in welcoming Shareef Hakim.
Hi, good morning, everybody. Amrit, Rudi, thank you. Today we're going to be talking about back to basics and network as an enabler. We'll start with personal introduction. So as Amrit said, I'm the executive director at Ford Motor Company and driving an organization called Systems Lifecycle. Our focus is on delivering system architecture, system integration for all Ford Motor Company vehicles. I have almost 2 decades in the industry of chip design as a developer. I joined Automotive, frankly, 2.5 years ago only. But before that, I spent time at Intel and started company delivering products that many of you are using this in graphics. I've led fairly large software and hardware projects and teams that deliver complicated projects across the stack, so starting from embedded software all the way up to cloud. And the most important thing that I'm asking everyone to keep in mind today is that I am not a network expert. I'm actually far from being a network expert. I rely on many experts. Some of them are here in the crowd. I don't deliver those products. When Amrit asked me to deliver the keynote, frankly, I struggled with that a bit because I'm talking to an audience of experts in domain I'm not expert in. But after thinking about it a bit, actually I have a thing that I can ask for your help. So think about this keynote presentation as an ask for help rather than anything else, and we'll go. The agenda at the high level of what we're going to be going through is we're going to talk about what is software, what's high quality software, what does it mean to deliver high quality software, and how that's measured. And eventually we'll end up of why that's important for the industry. We're going to talk about the complexities that the automotive industry brings. And we're going to compare it a bit with other industries in the time that we have. We're going to look at the future of automotives and keep some time at the end for questions and hopefully some answers to those questions. But let's start with the basics. What is software? I looked it up and I found it on the internet. A very nice description of what software is. Software, instructions that tell the computer what to do. Software comprises of the entire set of programs, procedures, and routines associated with the operation of the computer system or systems. Vehicle in general is computer systems that are put together. So the meaning of this, to put simply, is software as a communication layer between physical communication between hardware and a different entity. That other entity that communicates with can be another layer of software, or us, people, human beings. So that's the objective of software, is to be that communication layer between that physical element, between the implementation of the system, and whoever is using it on the other end. But what's the value of software? How do we measure it? And there are 2 values of software. If we start with the secondary one, is what the software is supposed to deliver, the functionality. What was the intention to have behind it? And does it deliver it or not? Does my car see it move when I intend it to move? Does my car play work when I plug my phone? And many of the other features and applications and software layers that are intended to be working on functioning. But that's the secondary value. The main question is, what's the primary value? And it is how easy is it to change the software. Software is called soft for a reason. It has to be soft. We have to be able to change it. The turnaround time, that's how its success is measured based on that primary value. Between a change in software to full deployment, successful deployment, that achieves the secondary value, which is the functionality is working. That's how we measure its success. That time has to be as short as possible. It cannot be weeks and months and more than that. And why is that important? Because even if I achieve the secondary value, and I can achieve it day one, right? When I launch a vehicle, for example, most of my functionality is working. But the minute we find an issue, and we do find issues in software, or the minute I need to update that functionality or deploy new functionality, and if it's not easy to do, then I've lost my secondary value. Then that secondary value is worth nothing, because I'm not achieving it anymore. And it's a key point that many software developers, including myself and people in my team, keep forgetting, especially in the rush of the world, and we need to get things out, we need to work faster, and we have the reason time. We forget that the first value is the most important one, which is software have to be software. Otherwise, it's not software. Low quality software is measured in different ways. The four main pillars for measuring low quality software, we call it smells, it stinks, frankly. The first one is rigidity, where a change in one software module will cause a change in another module, and it doesn't make much sense. Right? Changes should be encapsulated into the functionality of the system. Fragility, where a change introduces random failures. So I made a change in one module, now I'm running my regression testing, I'm seeing failures in other places, right? And that by itself is another low quality attribute of software. Opacity, it's hard to read and understand. Software should be beautiful. You should read it just to read simple English. It doesn't matter if you're a software engineer or not, by the way, or how expert you are. You need that software. You are supposed to tell what is supposed to deliver, what's the functionality behind it. Many times I show people in my team and other groups two pieces of code. One which is low quality code and another one which is high quality code. And they both deliver the same functionality. You can tell from one of them what it's really supposed to deliver, and the other one, there's no way you can tell without running the code and testing it and trying things out, figure out what's the functionality behind it. And again, you don't have to be a software expert to understand it. All you need to do is to know how to read English, and that's what it means to have high quality software when it comes to capacity. Interoperability, it's impossible to use. When I need to write functionality, I cannot use it in other places. I have to keep rewriting it, rewriting it, rewriting it. And that's another attribute of low quality software. There's another way of measuring low quality software, which is described in this diagram. We're not going to get into the details of it in this keynote, but I believe many of you who have attended code reviews can attest to this measure. All right, let's switch a bit to automotive. And again, I joined this industry 2.5 years ago. And one of the things I've noticed is that there is a look at legacy industry model of developing software. It's a fairly interesting one because it's very much vertical. So the implementation of software, when you look at it, is actually vertical from the feature all the way down to the physical implementation. Right? This obviously is a very rigid model that has very strong dependency with the physical implementation, which means that it's fragile, it is rigid, it's very hard to understand, you cannot separate that software and reuse it. So by definition, the previous slide we went through, if we agree on it, this is low quality software. This limited abstraction and feature-driven verticals means that our software development process is slow. It's not as soft. That turnaround time between a change and deployment has so many layers in it now that has to go all the way to the physical implementation that makes it much harder to make that change. And again, the problem with making slow changes, it also limits innovation rather than only hard to debug and to bring high quality software. Because the software developer, if they are unable to test their new idea fast, then they will not have new ideas. They will get failed to make them. And that's something we want to avoid as much as we can. And we do want to bring innovation to the Luckily, many of the OEMs, including the one I work for, have transitioned to a new model of development software. And that is defining abstraction layers. Some call it platform systems, some call it services, some call it platforms. Doesn't matter how we call it, but it's an abstraction layer that separates the physical implementation we're talking about, the physical attributes of the system, exposing APIs and interfaces for application layer to communicate. That's definitely best step forward. It does hide some of the physical implementation and makes the software a higher quality software from when we started with the physical implementations. That said, this is not the full solution. We are still seeing issues when it comes to that. And many of the issues we're seeing are frankly network related. And that's where I and many other OEMs need your help. When I was looking at the program, and I see that there are many topics that are related to people, how we can really improve the dynamic behavior of the system and make it more of a software-defined network rather than the rigid network definition we have today. Let's look at an example of how we go through updating software. We start by defining feature. There's a new feature we want to do. It's something that we can do in a new program or an already running program. We define the system that interacts with. We define the interfaces that new feature application will. We do the full feature design. And then we go into the fun journey. And this fun journey comes to, okay, we need to map the interfaces to the communication layer. So we just went down into the layers. We generate network artifacts like XML or BDC or flavor we're using. We generate final functional requirements for suppliers. We source suppliers. If there's no supplier that we have, usually we do the redundant system definition. We generate the base software using those XMLs and BDC that we have and all the attributes we just generated. We integrate that with the application. We test the software and we integrate that into it. That mark that we have here, that's not a one-week work. That is a multi-month effort that we have to go through. So, and again, there are abstraction layers. So we did the abstraction. We passed that point. We're not vertical fully anymore. But it's still not a one-week effort. It's not a one-week effort. Frankly, it's not even a one-month effort. It's more than that. So if I need to make a change into my application that, God forbids, will have an interface impact, I'm talking about a multi-month effort of making a software change. That, my friends, is not software. And that is going to be limiting our innovation and our success as OEMs and industry, frankly, or not only OEMs. Interesting thing about this slide, if you guys look at it closely, writing the software is not even part of it. It's not here. Because it's so small compared to the rest. Writing the software, it's like having developers sitting down and writing the code that needs to provide that functionality. The secondary value we talked about is not even on this slide. What's on this slide is really generating that. Is really working with the suppliers in order to get a base software and integrate the application. And that is the issue that I really need your help with. Right? There's no way we can be successful in this industry without resolving this issue. So, summarize, we have just built independency between the top of the stack, the application, and my network, which is a physical implementation rather than anything else. So I pass across all these stacks and I say, okay, I need to build a new application, I need to add a new interface. This means I need to go all the way down to my network. I need to change that. And that change can be in one ECU, but it can be many ECUs, because ECUs going all over the place. So that is a house of cards. For every change that I do in software, I have to think twice, can I do it or can't I do it? And the answer I get really depends on what's the impact to them. Not if my customer will enjoy it or not. Not will it bring the right experience to my customers, will it bring the right safety attributes to my customers. No. The answer I have is, how much time is it going to take me to update that? To work with the suppliers, to give them the XML, for them to give me back their software and application integrated and put it into full system integration and testing internally. And that's what we need to have, and we must solve this together in order to succeed. The good news, though, is that we're not the first in this journey. As I said, I come from a different industry, and at Intel, for example, I led their cloud efforts. Software defined networks is the thing there, right? I never had to think when I deployed something on the cloud, how it can communicate with another cloud. Right? This was never something I thought about. So there is that aspect of it that provides centralized management and flexibility of network management and configuration. IoT, when we talk about different things, when I go buy a device and plug it with my home, it connects to my Alexa perfectly. I don't have to go and define the network of that. I just need to configure the device, and that's it. It just connects to Alexa and communicates with it, right? There are the phases of identification and configuration that goes with it. But that's something that is managing the protocols that is provided. The third example, which is actually from the automotive industry, that many of you know about it very much than me, J1939. To be clear, I'm not saying that we can go all can and eliminate that of vehicles, no. But J1939 provides standardization of interfaces. It solves the problem, though a very unique one, but it's a solution to the problem. Is there a way we can expand on that to solve the problem ahead of us? Automotive brings complexities that other industries don't have. Industry I just mentioned. And we don't have the real-time and safety implementations as an example. We're driving vehicles, we're putting our families in vehicles, we do want to get from point A to point B safely. We want to make sure that the response of that system or vehicle is real-time, right? That's something that we don't have as much in cloud systems. So that is something that we have to be aware of and make sure that it makes the solution space a little more complicated than it is. Automotive industry brings tons of technologies. We were just chatting about it here, right? Where there's LAN, there's CAN, there's Ethernet, there's also classic, there's also adaptive, QNX, Android, gas, you name it, all together in one vehicle, right? So feels like there's everything in a vehicle, and we're asking to standardize somehow this communication. That obviously makes it much harder. And we need to solve this complexity. So another thing, what can we reduce this complexity and how can we make it better? Constrained microcontroller and limited memory. Cost is very important in automotive. Packaging is also very important in automotive. In many cases, most of the ECUs have very limited microcontrollers rather than big SoCs that we have on other automotive devices. Having considered microcontrollers, we can run less levels of software. And you are limited in what you can deliver on those ones. There's another aspect of required determinism in these systems, and they're statically configured most of the time. Those are complexities that the automotive industry brings. And with them, if we compare to the previous slide, I was referring to this one with the solution here. The complexities make those solutions much harder. Is there a path to solve it? I'm sure there is. Do I know what's the path to solve it? No, I don't. But that's where I surely hope that many of the discussions with you are going to be in this conference, going to be related to this, how we can really solve it and advance this industry. The path. One thing I know is the path to really improving that development philosophy we talked about. Again, we started with the fact that software has to be soft. And we ended with the fact that we've done a lot. and we're still not solved. It takes mathematical change. What I know, though I don't know how to solve it, but I know that there is a path to solve it, and it requires collaboration across OEMs and suppliers. Right? I think that if we work together as a community, there's a path to solve it. And to deliver that robust development process we discussed. If you look at the OEM's responsibility, we as OEM, this is the chart I had before, where you can look at, okay, we have the presentation layer on top, we have the application and the feature, and then we have the services or platform systems we talked about. The OEM responsibility is really to provide unique customer value through platforms. We need to provide those platforms, this abstraction layer we talked about, enable those interfaces to the top layer that provides appealing applications, features, user experiences, interfaces to our customers. That's our responsibility. This is what we sell. This is how we make money. But what we need to do is, we need to also make sure that we get standardized development interfaces from suppliers. Meaning that, as an OEM, we need to start shifting our thoughts into, rather than me telling the supplier what interfaces need to be delivered, it's like I think the supplier has to tell me what our interfaces need to be. A seed module is a seed module. It goes up, it goes down, it goes forward, it goes back. That's what it does. Those are the physical attributes of it. A supplier needs to expose those fully in a way that's standardized that I can consume. I might not use all of these interfaces in my applications, that's fine. But those has to be exposed to me as an OEM and integrated into my platform or that abstraction layer that I just built. Supplier responsibility, I believe that the supplier responsibility is actually bigger. Not because I work for an OEM, but I do believe that the supplier responsibility is bigger. I truly believe that suppliers can transform this industry. There's a lot that can be done. And that's because you work with people and you deliver those physical attributes, the basic functionalities we talked about, the different modules, the different PCBs, many of those are delivered by suppliers. You know what the modules can deliver. You know what are those physical attributes. You know everything it can do or can do. It would be great if we can standardize the way that you communicate with the top players. If you can tell that actually from the OEM, okay, these are the interfaces I have, and this is the way you communicate with me, rather than wait for me to give you the answer. Now, that requires a lot of standardization and work across the different groups and the different OEMs and suppliers. I'm not saying it's something easy and can be done tomorrow. But if we agree that this is a path moving forward, then what's the first step to go with? All right. Thoughts to consider. And if we look at the J1939 concepts, and again, I'm not saying that we need to do it as is, I'm not saying that we need to all go back to Canada. I'm emphasizing the fact that just standardization itself can be a good way to do it, to solve the problem that we're discussing. So we look at addressing, unique addresses for each device with simple dynamic management, there's no doubt about it. Right? It adds complexities of, okay, now I have to define those unique addresses, we have to come together as a standard, come together as a community, and this is something that there's a lot of work in. Whether J1939 also have complexities and cost of funds, so we want to avoid those. But the concept of having unique addresses is important. Name-based services, where components discover and interact based on functions, that's another key thing in order to solve, or a way to solve this problem. Parameter networks, standardized data path, vehicle speeds, use data. Every vehicle has a vehicle speed and it is consumed by the modules. Communication, broadcast, use broadcast excessively, and dynamic configuration, where we have runtime configuration changes rather than compile time or real time. Those are key because that will bring more dynamic behavior to the system. IoT protocols, again, we talked about quality device. It goes through multiple phases. 4 of them are discovery, where okay, the device shares the metadata, the profiles and identification that's needed for the device. Then we move into the identification phase, where what's the device type, what are the protocols it exposes, what are the APIs it has. registration will become part of this platform that we're building, which will be in this case. And last but not least, configuration. What's the network attributes of this device, authentication, and does it have the latest software or not in that case? I'm not saying this is something that can be done, obviously. When we talk about microcontrollers, we talk about the complexities of automotive. When we talk about microcontroller better than memories, and we don't know what you can do here and whatnot. But the most important thing in this slide is actually the last thing. I think reducing the complexities both in the software stack and the hardware will make any solution when users will decide to go through more feasible. Right? The fact that we have so many technologies used, each has its own pros and cons, don't get me wrong, but there's so many of them, and they're very different. Both on the software and on the hardware makes any solution, reducing that complexity, make any solution that more feasible, obviously. With the amount of layers we have and technologies that are used, it's much harder. And I'm not dismissing the fact that a huge part of this industry, including the company I work for, there's tons of legacy. These are companies that have been there for 100 years. And they have built over these 100 years, and they built lots of technologies over these years. They built tools that are used. It's very hard to switch it and to move to different technology layers. But you can start marching towards that. Call to action is this one is actually important because I don't think we understand how existential the ability to update software is important, is essential to OEMs. If OEMs will not be able to update software and make it really soft and change it all the time, in the future, in the near future, then we have a major issue. We have a real major issue because some other ones are doing it. And we're not even going to be able to bring the experiences that our customers are going to be used to, our customers need. We're not going to bring the automations that we need. We're not going to bring the ADAS features that we need. We're not going to bring many of the things that we need in their daily life moving forward. And they're going to be seeing it and used to it. We have lots of industries that are bringing these values, and we as OEMs, we have to move forward with that. And there's no way to move forward with that without the ability to change software and make it soft. There's no way to do it without the separation between the network layer, the physical implementation, and actually the application layer that's built on top of it. Network in automotive bring complexity compared to other industries. Again, I shared with you the pain we're going through. Automotive bring complexities compared to other industries. I'm not dismissing that whatsoever. But do we really have to live in that pain, or can we really improve it? Can we do something more different? Can we bring software-defined network, for example, in some form or shape into automotive? Can we align the complexities of using the different stacks and different hardware? Can we do standardization between the suppliers, the OEMs, the customers, and use that rather than have this ping-pong of me sending you the BBC, you sending the patch software, we integrating, it's failing, and we go through that around again and again and again. So, my ask to you, if I may ask something, is we must find a path to remove this complexity. This is very important for everybody involved in this industry, suppliers and OEMs as well. We have to find a way to work together in order to come up with a solution. In the form of standardization, when using new technologies, there are many things that can be discussed to bring this solution. Thank you very much.
If you have questions, we have a couple of microphones up in the middle aisle there, so please step up or raise your hands. Answer any questions for Shareef. Got me one. All right, I see one here. Okay.
Yeah, thanks very much for the So, software-defined networks, you talk a bit about plug and play. And if you have, I can see how the way you talk about plug and play relates to being able to create new data flows and modify data flows across the hardware that you have with your network in the vehicle. Do you also see that applying to changing the hardware topology of the networks in the vehicle at all, now or in the future, or does that aspect of the configuration, the plug-and-play, always stay fixed?
So changing the topology is a much harder task to solve. I don't think that this is how we focus on the one. But the first one that you mentioned, where I can change the module while we take the same topology, or add an to the physical module that is there, is something that has to be done. Topology doesn't change as much, right? And usually it's driven frankly from network choices in many cases, but those can be manipulated. So that's something that don't change as much, nor is it affected by the software. The objective here we're trying to bring is how can I separate the software development versus the network and the hardware communication. So that I don't see topology changes as a priority in this.
Any other questions?
I think this covered a lot of really important items, and you have the call to action right on the slide. I was wondering, do you have any thoughts on how and where the industry can configure to address those so that these relevant questions don't go proof after the conference?
Yeah, that's a good question. I think in every change, by the way, and I'm sure many of you have seen that curve of we have early adopters and then we go to the maturities. I think we need to define the early adopters of, okay, who are the key companies, OEMs and suppliers that are willing to sit down together and figure this out, just put a whiteboard and start going through ideas. I don't know who those are, but I can tell from my perspective as an OEM for supporting this conference and whatnot, is that we are willing to be that clear and work with the suppliers and other ones to do. Now, I'm not a fool. I don't think everybody is going to be on that table. I'm sure many will not be ready to do that, which is fine, right? Because every change has this curve of, okay, we start small and then we'll go because it's going to be successful. I think the right thing to do is to use the opportunity of the conference that is happening here, really, and figure out who's there and people that are willing to do it for this, start discussing. Let's agree that this is a problem first. Now, what's the path to solution? Because it is going to impact every each one of us, and we're willing to do that.
Other questions? Going once? All right, I'm not seeing any other hands, so we're great. So, great.
Thank you very much.
Thank you very much.